All right, so let's now talk about what a confidence interval is and what good can it bring for us and a general method of how to find a confidence interval. And so now the main idea here is that the goal here of any confidence interval is to estimate a population value okay, and so a population value in our learning mu symbol, population mean, is a population value that I'm talking about. In some advanced work in stats, you are also required to estimate a population proportion. So these are all what I so call a population value. And the reason we set our goal to estimate a population value, such as mu or p for population proportion and population mean here, is because a lot of times these population values are unknown or very hard to calculate the precise value. Or for example, as a population mean, we can look at the mu here to be national mean gas price. Because to find this value, we have to go through the entire population of gas prices out there and to average out. So this value is usually unknown because it's very hard to find. Simply the data here is a national data, very big data to just calculate that value. Or as a population proportion here, a population proportion can simply be something that represents the proportion of iPhone users. So to find this proportion value, now I see this proportion value here as a population value simply because to know this proportion of iPhone users, we have to go through the entire population of cell phone users just to find out what's the proportion, what's the percentage of iPhone users out there. And there are a lot more applications of population proportions out there. We can also study about a proportion P, that is the proportion of heart disease patients. Okay, and so a study like this, a study of this kind of proportion is very popular among the medical experts, among anyone who is working in a healthcare professional. Or another quick example to think about a population mean value. Population mean value right here, we can measure this can be the mean lifetime of pine tree in a region of the world, or it could be in the entire world. But so I just quickly point out a few different population values that that the scientists are interested in studying, and these are all population values. And so thinking about these population values, they are very hard to find specifically because any of these here lead us, calculating any of these population values here will lead us to work with very large data. So usually we won't be able to obtain the big, precise, the good, precise value of any of these population values. And outside of these quick examples, there are a lot more examples about the population values, and it all depends on what you learn and how you apply statistics into your own field out there. And now along the way, as I introduce the term population value, then it's also good to know a new terminology in statistics right here. A population value that I have pointed out a few examples of. And these are not the only ones. But a population value, any population value as a population mean or a population proportion, and in even more advanced studies, there are population difference of means and all that. But basically, a value that we obtain from a population is called a population parameter, or for short, just a parameter. And so a mu is a population parameter, a p is a population parameter, and you have seen in your earlier studies that we can also have a population standard deviation. This is also a parameter because it's a population value. And so now, let me now explain further why we have this goal to estimate a population value using a confidence interval. Because as I was saying earlier, a confidence interval is its goal as a goal is to estimate a population value. But why do we have such a goal right there? Why do we need to do such work? Because just now I have explained, calculating the actual value for any of these population values is not always an easy to be done job right here. And so the idea now is that instead of calculating the precise value or the exact value, which requires a lot of either computer power or manpower, then we now can come up with the idea that we can only estimate. And so now anytime it's estimate, that means we come up with a low end. We need to come up with a low end and a high end. And between a low end and a high end, we expect our population value, or now formally our parameter, to fall between this interval. So the idea between a low end and a high end, it's an interval. So if we now looking at coming up with an interval, having low end and high end, to expect our population value and any of our population values here, or any of our population parameters, to fall inside of the interval that we came up with. And so after constructing the interval or finding the interval, it also comes with a certain level of guaranteeing how successful this interval will work, will contain our value. And so that's why it's called, see, in its truest meaning, it's an interval. Having a low end and a high end is an interval. But now, once constructing it, once successfully finding it, it has a certain level of successful, and that's why we call it, it's a confidence interval. We want to come up with the interval at different level of confidence that the value we're aiming at to estimate will fall in between. And that is just a quick, brief explanation of what it means by finding a confidence interval, what it is, and what good does it bring for us. And now let's look at a general guideline, or here let's call that, it's a generalization of how we can do it. And then after this general discussion, we are going to have some actual example. And now let's say I'm putting up a scenario here. If we are working with a if we are trying to estimate an unknown population mean value, then, as I have already explained, finding the exact value is a lot of times difficult, or to the extent almost impossible, because the population of values is too big out there. So what's easier for us now is that we are going to find a sample. So we're going to find a sample. And so, being different from a population value, a sample value is only a small collection that we picked out from the population. And so here, if we are particularly looking at estimating the population mean, then the sample value here would be correspondingly a sample mean. And so it's capital X bar. And so that's the idea right here. So we first find a sample mean. And so a sample mean usually comes with a given sample size, capital letter N right here. Because anytime, and you have seen your study regarding sampling distribution, so anytime we pick a sample, then we must know, and that's why I'm saying given N. So anytime we are picking up a sample to calculate our sample mean, then we must know for ourselves already how big our sample size is. So that's why I'm saying we can just find the easy work here to estimate mu. We find a sample value correspondingly, and that sample value is a sample mean here in this case, and with a given N, with a given sample size. And so now, but once we picked up our sample mean value, then imagine the idea is like this. These two values are all numerical, and so on the line of number, our unknown mu can be anywhere. And again, mu or population mean value is unknown. But the sample value we have found here is our sample that we purposely selected for our purpose. And so of course we know our sample value. So once we calculated our sample value could be below the actual unknown population mean. Or in other case, our sample mean could be above. So these are different chances that can happen. So these are all different values that can possibly happen for a sample mean value. And so the idea now is that from any sample mean that we have found, we are going to calculate. So that is now step 2. We are going to calculate a margin of error. Okay. And so this idea of margin of error is as following. Say if our sample is here, and of course in the end, the actual mean, the actual population mean is still unknown. So really our sample is just anywhere it can stay here. But the idea now is that from where the sample is, we are going to calculate a margin of error. What is a margin of error? A margin of error is an amount that, if we take our sample mean as a center here, then we're gonna add. So from where our sample mean here is, I'm gonna add the margin of error. So margin of error is symbolically notated by a capital letter E. So it's a quantity that I will eventually show anyone how to calculate. But from where the sample is, if we can just simply add that margin of error to our sample means, then we will produce the upper end. And so with the same margin of error here, now with our current sample mean we already had, if we can just now subtract this margin of error away from the sample mean, then we will produce the low end. And so that's here from low end to high end is what I call the confidence interval. And so after calculating a margin of error, step 3 right here is to produce the actual confidence interval. So allow me to use the shorthand symbol. CI stands for final confidence interval. It's in the form of from where your sample value is, we are going to add and subtract. So it's actually two different works right here. We're going to add and subtract from your current known sample mean with the margin of error. And then this is how we produce our final confidence interval. And so another way of seeing this, low end of this interval, according to the picture here, as I said, we subtract the margin of error from the sample mean we've had to come up with low end. So another way of saying low end is from where our sample mean we already found, or sample value we already found, subtract the margin of error. That's low end. And from where our sample mean is, we adding the margin of error. And that is the upper end. And so same way, so now back to this picture right here. Same way, if our sample mean is, or happens to be above the actual unknown mean value, then the same way right here, we're calculating the margin of error and add, allow me to use dotted ink right here, add the margin of error to the sample mean, and we have the upper end, and subtract the margin of error away from the sample mean, and we have the interval in dotted ink right here. And so that's the reason why now to re-emphasize the meaning of a confidence interval. In the way how we build this, any of our confidence interval, it completely depends on our sample means that we have found. So for that reason, some sample mean is lucky for us that's close enough, so that after we constructed our interval this way, by shooting out from where our sample mean is with a margin of error to the left, to the right, then sometimes that we're not lucky enough, our sample means will be far enough, and even if we already shoot out the interval, the actual value is still bouncing off the interval. And that's why I'm trying to say there's a chance that we're unsuccessful, but higher chance we should be successful in this way. And that's why there's a concept about being how confident our interval is. And so similarly, for people who are studying about a population proportion, if you have to calculate, or if you need to, according to your work, to calculate or to estimate a population proportion value, then the same step, according to what I've written down earlier, then first step here is to find a sample value. A sample value, and in this case here, corresponding to our target here being a population proportion, then the sample value here makes sense to be a sample proportion. And sample proportion is notated by a lowercase letter p. And lowercase letter p very similar with lowercase letter p here for population proportion. So to be a sample value, we put a hat here on the lowercase letter p right here. So once again, first step in estimating a population proportion value, we find a sample value, namely a sample proportion. As symbolically, it's a lowercase letter p. And of course, with a given sample size, letter n, because again, a sample is what we purposely find, so it's always easy to find, and it's always with us. Other than that, the actual proportion value here, if we want to calculate the actual population proportion, we must go through the entire population, which is a lot of times very challenging or almost impossible to find. And once we have found a sample, then again, think about the idea that the sample we found, the actual p is again unknown, and that's why we're in the need to estimate it. But the sample value we found could be lower or it could be higher. We don't know, compared to the actual unknown proportion. And that's why in that way, now you have seen my explanation for estimating the population mean. So here it would be the same. The next step now is to calculate the margin of error. And again, the margin of error here has symbol capital letter E, because what exactly is it, and what do we do with that? The margin of error is again how much we are allowed it to either add. So from where our sample proportion is, we can either add that margin of error to produce the higher end of the interval. Taking p hat here, taking our sample proportion here as the center of the interval. And then same way, once we have calculated our margin of error, then we can subtract the same margin of error from the center p hat value or sample proportion value to produce a low end. And that's how we complete our confidence interval. And so again, final confidence interval, once we have found the margin of error, is to be found by from where our sample proportion value is, we are going to add the margin of error to it to find the upper end of the interval, and as well as subtracting the same margin of error from the sample proportion value to come up with the lower end. So this is the way how we construct our, or how we find our final confidence interval. Or similar to how I was explaining when it was population mean estimation, then here we can also write our interval in traditional format showing low and high. So low would come out from p hat minus the margin of error, and the high of the interval would be from where p hat is, we adding the margin of error. And again, same fundamental, because the way we're constructing the interval like this, it entirely depends on how we found our sample. So sometimes when we're not lucky enough and we found a sample proportion that's far enough that even if after we add and subtract the margin of error to come up with the interval, the actual proportion can still fall out, it can still have a chance to fall out of the interval. Okay, and that is the reason why there's the fundamental about how confident your interval can be, and all that is the concept about finding a confidence interval. And last thing before we close down this general lecture, this general discussion, and ready to head out for actual examples, then I need to also mention that, so now we call that our interval is a confidence interval. So a lot of time, and anytime we're finding a confidence interval, a confidence level must be specified. So anytime you're given a problem that's asking you to find a confidence interval, then the problem must give a specific confidence level. So that's what I was saying. A confidence level must be specified. Or if you are that person to find a confidence interval yourself, you can decide a different confidence level right there. But we need to have a confidence level, and confidence level lowercase letter c in a lot of, throughout a lot of textbooks and throughout all of my video lectures here as well. But even though, be aware that some textbooks might use a different symbol for that, and in the problem is usually expressed in percentages. So these are a few things to know about what a confidence level is. And so now any confidence level, I mean, the specific confidence level is to indicate how you want your interval to be successful, how successful you want your interval to be.